is Rishi, I'm Rob, this is Joe, and two of our students, Rohan and Neha, who will be talking to you in a bit. But yeah, so this is something that we can use. At the moment, we're just using it for Key Stage 3, but obviously it's got scope to be used in Key Stage 4 and Key Stage 5. It's a simple thing, but it's something that has worked really effectively this year, and we've had a lot of students actually quite enjoying it, taking charge of actually doing something outside of the classroom, challenging them. There are all sorts of different levels. This session is going to be a slight sort of eclectic mix. I know it says bite-sized ideas in maths. We kind of, our head of department gave the title before we were actually told that we were presenting. So there are going to be some bite-sized ideas in maths. There's a lot of ideas that we're not going to be able to talk about now because obviously time constraints. But at the end, on the slides, they're going to be uploaded apparently to the What Works website. And there are lots of other ideas and more explanation on some of the things that we're going to talk about today, and extra sort of investigations, etc. I think the students they have to get the school bus home, so they're gonna go first and talk to you about another thing that they've introduced this year, which is peer mentoring. So.
Good afternoon, I'm Rohan.
And I'm Neha.
We'd just like to talk to you about the maths mentoring program that we've established this year at Dubai College.
Maths mentoring was started this year as a way to help students with maths, and it supplements their in-class learning.
Basically, it's an attempt by us to readdress the topics that the students have already learnt during the course of the year to keep it fresh in their minds for the end-of-year exams.
Essentially, maths mentoring is conducted by Year 12 and Year 13 students for students in the younger years.
Okay, so the structure of maths mentoring is we have one 40-minute session a week, generally, and each one of these sessions is led by a Year 12 or 13 student, an elder student to the person who's being taught, someone who's already done that part of the course. So although we run once a week, we do also do separate sessions if the student requests it throughout the week.
The sessions are also conducted in small group learnings, which means that there's 1 to 2 mentor to student ratio. This therefore allows individual attention and concentrated teaching, and therefore further enhances their knowledge of the subject.
And the topics that we go over in the sessions, they're chosen by the students. They decide what they want to go over. This is usually based on the stuff that they either find hard or things that maybe they've forgotten. And so they tell us what they would like to go over before.
The topics they tell us beforehand, which gives us time to prepare any questions or allows us to read up by ourselves so that we can answer their queries. Alternatively, we allow the sessions to be walk-in sessions for students who don't always attend regularly.
The structure of maths mentoring, when we created it, we tried to make it as flexible as possible so that it can work around the students' needs, so to help them the best. Okay, there are a few key differences that we'd just like to tell you about between maths mentoring and regular teaching. Obviously, the fact that it's taught by students is the main one, but the small group structure, as we said earlier, it's 1 to 2, allows students who are less confident in lessons to ask questions more freely, and maybe in a session where there's 20 other kids in, they'd feel the peer pressure to just go along, but in mentoring they can ask questions without feeling intimidated by their peers.
As a student and as a mentor, we work together on the question and the queries that they may have, bouncing ideas off of each other. Again, this allows closer supervision and instruction, and it helps create a collaborative environment, which obviously enhances their concentration and their understanding of the subject.
Okay, and the other great advantage about the small group structure is that because there are only 2 kids that you're working with, they can dictate the pace that they want to learn at. So if they find something hard and then half a session later they decide, okay, I understand this now, you can move on. Alternatively, if they say, okay, no, at the end of this session I still haven't fully understood this, I'd like another session on it, they can decide and you can really tailor it to their needs. Okay, so I guess a lot of you right now are pretty skeptical about why mentors would be willing to give up their time. And one of the things is that maths, unlike many other subjects, you have to carry your knowledge through, and everything you learn is based on your understanding of other previous topics. So if you are reteaching those topics, it helps to build a solid foundation for yourself so that you understand your next topics better.
Probably the most prominent reason and the most selfish motive, I guess, is that maths mentoring can be written on the mentor's university applications. Also, any Year 12 or Year 13 students who engage with the program can use their time as credit for community service awards such as the Duke of Edinburgh Award at our school.
So in the future, we'd like to expand mentoring a bit. One of the ways we could do this would be to use mentors to assist teachers during lessons. So for instance, after the teacher has explained something and the students are doing their exercises, if a student gets stuck on a question and the teacher is preoccupied helping another student, then a mentor could step in and help a student out with their question.
We also plan to have revision sessions and clinics closer to the exam time near our public examinations in the summer term. In those sessions, we go over exam practice and again over any topics to ensure that they succeed in the subject.
And in general, we'd like to broaden mentoring to other year groups and to other subjects as well.
So right now, does anybody have any questions in specific for maths mentoring, just to us two?
Because we have to...
That's the nice work you are doing, and I appreciate. You better go for enlarging that things.
Thank you.
Thank you.
Any other questions?
Any questions?
Yeah, how do you arrange your sessions? Because now I think you're in grade 12 or 13. How about your regular classes?
So what happens is in our school we have an allocated slot around midday between our sessions, and during that time throughout the school they have different activities such as PSHE or study time. So we use that time to do the maths mentoring, and students who would like to come along come to that specific classroom.
Alternatively, I know a lot of schools don't have that prep session, as we call it. So we do also run sessions during lunch, as I mentioned. If the student requests it, then we'll run it during lunch break to help them out with something.
Do you take only one or two?
Any
One you mentioned about the benefits and benefits, university application. What is university application?
So we would be, when we apply to university and it asks us what kind of things have you done to contribute to your school, or in terms of if we were applying for maths, we'd use maths mentoring as something to show our engagement with the subject, our initiative with the subject.
A lot of US and UK universities want you to be passionate about your subjects. They want to see what you've done outside your curriculum about your particular field.
Who guides the mentors?
The mentors are teaching the courses that they have previously done. So, for instance, in our school we have 2 separate courses that can be done at year 11. So you will never have a mentor who has not done the more advanced course, teaching the more advanced course. You teach the course that you've already been done. And occasionally our head of maths sits in on some of the sessions just to help out.
Thank you so much.
Thank you very much.
Okay, I just really champion that. It's great for us as teachers because, I mean, we're lucky. I mean, maybe we're very lucky with our students, but they're absolutely fantastic. To be able to give them something and run with it, I mean, it was amazing. And in fact, it wasn't something that we asked them to do. It was something that this was an initiative that they came up with purely on their own. They came up to the head of maths at the beginning of this year and said, "Look, we'd really like to run this program. What do you think?" And they've done all of this independently on their own, and I really champion trying to use your students as a resource they are a fantastic resource, and giving them that opportunity to actually, they really rise to it. And I mean, you can see by the way that they talk and present, they're so confident, and they're absolutely fantastic. So we're just going to now carry on with just a few of the bite-sized ideas. Anybody seen KenKen? This is something we use. I'm sorry if these are things that you may have already seen, already done. Some of you might have done. But has anybody seen KenKen? This is something that we use quite a bit as like a starter activities and things in our school. It's a bit similar to Sudoku. Everyone know what Sudoku is? Yeah, most of you know what Sudoku is. So it's very similar. It's just got a slight extension to it. So, for example, this is a very basic 3x3. So the numbers, as in a Sudoku, your rows and columns have to be 1, 2, 3. You can't have. So I couldn't have a 1 here and a 1 here. They have to be separate. 1, 2, 3 in each of the rows and columns as Sudoku. So the slight difference is that these two squares here the two numbers have to add up to 5. So the plus there just means add up to 5. It's pretty straightforward, really. You get the hang of it quite quickly. So here, in this top right-hand corner, there's only one number. So obviously, we look at this, it's got to be a 1. So now at this point, we go over to this side. So again, this is a very basic, as simple as it can, pretty much as simple as a KenKen can be. These two squares here have to add up to 3. So obviously, the two numbers have to be 1 and 2. But this one can't be 1, so this has to be 2, 1. Yeah, you get the idea, hopefully. Okay, at this point, these two squares have to add up to 5, so it has to be 3 and 2, etc., etc. So you go through, and you've got therefore you've got your KenKen. There's a website, www.kenken.com, I think. Just let me check. Which is www.kenken.com. It's got how to play, so it's got a much more explanation. But it's really good. It engages the kids. It's good for as the pupils are coming in, especially if you've got large classes, getting them having something ready for them to do where they can quickly sort of work it out at the beginning. But this is something that actually has been published. Quite sort of maths professors have looked at and published in articles, and it's to do with problem solving. It's great for the pupils' problem solving, for their reasoning, mathematical communication. It's great for the perseverance. As you get to some of the more difficult ones, like you can see here, like you can play up to the 9 by 9. You can have so these two numbers have to subtract to make 2, etc., etc. They get very complicated. So the mathematical reasoning, the perseverance, and also obviously the mathematical skill of making sure, looking at your result, and actually making sure that your answer is a sensible answer. So there's lots of kind of mathematical skills and things that you have to look at for KenKen. So that's that's something that we've used a lot, and the pupils really enjoy it. It's good fun. So.
Okay. So I'm going to hand these out.
Yeah, I'll do that.
Okay, brilliant. Another thing that we use quite a lot in our school, just introduced this year actually, something called Tarsia. I'm not sure if anyone's actually come across that before, and we actually use it quite a lot because it's actually a fantastic resource for consolidating learning, assessment for learning, maybe for group work, things like that. It's just a slightly different approach to the usual way of grabbing a textbook and making them do questions. Unfortunately, the software does have to be installed, so you must speak to your IT department, or if you've got a laptop, you have to install the software, but it's completely free. It costs absolutely nothing. All the links and stuff are on the slides a little bit further on. So, okay, it's really good for plenaries, really good for starters. You can make it as basic as you like, or as complex as you like. I use this in my A-level classes, I use it in my Year 7 classes. Completely different classes. Very different approach. Revision purposes, towards an exam time, you might want to focus, say, on a particular topic. You say, look, here's a particular topic, work together in pairs, see how far you can get. Right. And it's a great approach for assessment for learning. So if you want to sort of assess how students are with a particular topic, it's really good, because you could notice straight away. Those kids who, get it all completely right, you're like, okay, bang on, they know what they're doing. Those people who are struggling, you'll see that they have a few cards here and there, maybe joined together, and they're thinking, okay, I really don't know this topic, and then you maybe have to go and consolidate their learning a little bit further. Teamwork. Now, I'm not sure in many schools whether they do a lot of teamwork or they like have a whole single approach. In my lessons, I like them to work very well together because I believe you can learn off each other. Just like the mentors, you know, students learning of students. It's really good, and they really do help each other out. To advance them, what you could do is you could start leaving gaps. So leave gaps in there, see if they try and find the answers out themselves. Get them to make their own tarsiers. Okay, so you push them on. You're differentiating the work as well. As you might notice as well, we've given you loads of different colours. The reason behind that is, if you keep them all in separate colours, you just get them back, nice and easy to collect together. You can reuse them again and again and again. Otherwise, you'd be there all day, cutting up these triangles all the time. And then what will happen is you'd end up with a solution that looks similar to this, and it will come together. Now, sometimes you get octagons, you can get triangles, you can have follow-on cards. The software is really, really easy to use. But one of the best things is, if you go to the website, that's on the slide, there's actually a bank of like hundreds of these that people have already made. And rather than reinventing the wheel, you could just use what's already there. In honesty, I did not do this one. I got this from the website and I've used it. Okay? You could do exactly the same thing. Just use what's available to you. Okay. Now, one more thing that I like to do as well is use plastic wallets. A little bit further. What I like to do is actually use plastic wallets. And in those plastic wallets, you can just print out a sheet and you can reuse these all the time, over and over and over again. I use it really basically. So, for instance, if you've got these grids, you can put number systems on there. They like do add-ons or algebraic add-ons, and they can start off making them as difficult as they like. The good thing is, if they're making mistakes, you could just get like a board rubber, you could rub it out, and it works fine because if you know on a plastic wallet, if you write on it, it just comes off, right? So you can see it straight away. These things, now, one thing that I've always found is a lot of students hate drawing graphs initially, hate plotting coordinates, they really struggle. But if you've got it printed out over here, really basic one, they can just start straight away, build up their confidence. These are so good to use, and they're really cheap. The other thing as well, if you really want to go for it, I use this actually with the two students that were here before in my mechanics lesson. And they really struggled with forces in mechanics, how the forces all work. So I pretty much print off a diagram, and they've got to draw the forces. If they got it wrong, I'd come along, like, wrong, wipe it all out, start again, until they got it right. You know, I mean, you could advance it, like, if there's friction involved, how does it happen, you know? Get them, you can push them on. That's what these plastic wallets, I find invaluable in some of my lessons. Yes.
When they finally do get the correct answer, do you let them then take it out and write it on the...
Yeah, this is up to you how you want to do it. Sometimes you might want to give them an advanced question, another printout that they can do, or you can get them to copy out into their books once they feel more confident. It's just in those initial stages where where they make those mistakes. So make the mistakes on here, so then they learn from those, and then they start to work in their books. But you could take any approach that you like. These are the approaches that I take. With different classes, I take different approaches. It's completely up to you. Just to run back as well, do you remember how the Tarsier had the printout of the solution? What's quite a good idea is what I do, I had that solution already printed out, and I'll have it cut, the kids cut it out and they stick it into their books. And what they do then, they peer assess and they self-assess themselves to see how well they did on that Tarsier task as well. So you can actually print out the solution and give it to them as well afterwards, and they can self-assess, peer assess, whatever you like, you can assess them. Completely up to you. Right, so I'm just going to pass you on to Jonah.
Two observations from today before I start talking about the topic. First one, that the word imagination was used a lot in all the presentations I went to. And then at Dubai College last week, we had something called the quote of the week, which was from Albert Einstein, saying that imagination is more important than knowledge. So I thought, well, should we change the KHDA to IHDA? I thought. Second observation, nobody has said that my students get a kick out of doing hard maths. I'll come back to that in a moment. In the meanwhile, let me talk about this top-up. He's my IT technician. Right. The first thing, top-up is an initiative that we started at Dubai College in September, and it's to try and top up the numbers of students we've got going to the top universities, i.e. the Russell Group, Ivy League in America, and Oxbridge. The students at Dubai College, in the main, will be going to the Russell Group, so we're focusing at the moment on Oxbridge. Before you go any further, the first thing was to identify the students. Now, I went back as far as year 10 moving into year 11 and looked at their performance at the end of year 10. So by the start of year 11, that's the current year 11 cohort that we have, I've identified now students who I think, and I haven't had a word with the headmaster yet, or the head of sixth form, but I've made a list of the students I think by the time they get into year 12, 13, should be considering Oxbridge and Ivy League. So, once I've identified these students, this is the present year 11, I will address them next term. For this term, I've concentrated on, by the way, the students applying to any subject, not just maths. Now I'm focusing on maths. What I've had to do is to try and get the students ready for Oxford. This is the Oxford Maths Assessment tests, and STEP. That's the 6-term examination papers. Now the 6-term examination papers are required by Cambridge and Warwick, and they will be done at the end of the A-level course. So that's the con. However, the maths for Oxford, that exam has already happened, and so that is one that you can do in your head actually. And the solutions are later on in this slideshow. For the I through to I, you'll need to know complex numbers, and that I is the square root of -1, and you'll also need to know the exponential form of a complex number. And the critical part of it is that the I through means raised to the power 1 over I. Like the square root is power 1 over 2, cube root is 1 over 3, the power 1 over I. Okay? And that's the thing that throws the students. If you were to write it down for them, they'd be able to work it out. You'll see in the solutions, it's just one line. But if you actually say to them in words, what's the I through of I, it stumps them. And it did the students who I interviewed on that day 3 weeks ago. This is another one. Which is bigger, e to the pi or pi to the e? And the solution to that took me quite a while. But it can be done in about 6 lines, much trickier than the first one. So when I say hard maths, I mean maths to get a student to study it at university. That's what I mean by hard maths. Getting them prepared for the math, one of the questions in there, in that, this is the Oxford entrance exam, one of the questions, the first question is multiple choice, and that is worth, let me think, 40% of the paper. So I concentrated on getting some multiple choice questions. Obviously I can get off the internet past papers, but I have also a bank of ISMTF questions. Has anybody heard of the ISMTF?
Yep.
Yep. This is the International Schools Mathematics Teachers Foundation. They run a maths competition in Europe every year at senior level and junior level. This year it's going to be at Waterloo in Belgium. It's going to be held at the end of January, and I'm taking 6 students along there. Now, the type of questions you get in those competitions are pretty similar to this first question that I was talking about in the MAT for Oxford. So to give you, if you're interested, an idea of the type of questions, rather than copy out an old paper from Matt, I copied just a couple of sides of the type of questions they will be getting at the competition in Waterloo. This is a page of 5 multiple choice questions. I'll just leave them on here for you. If you're interested, take one. If not, just leave them and I'll find a use for them. Each question is 2 minutes in length, so they get them in rounds of 5, 10 minutes to do them, and they've got 2 minutes. Now, when you first start doing these, you think 2 minutes is ridiculous time. You think you need 10 minutes to do them. Of course, it's like all maths. Try it. Practice. And the students, you see them improve because this is the type of question they're not used to seeing. It's a bit like puzzle maths, I suppose. But puzzle maths at the highest level. So if you're interested in this, you can just pick up a copy on your way out. I did have a slide, but I think you've moved it to the end, which is the solution to these two, and you will be able to find the slide on the website. Oh, it's
there, but you want?
Yeah, but you can get it later. That's me finished. Thank you.
Yeah, like I say, we were kind of, this was a bit of a last minute thing for us, so I mean there's just a few things. What we've done is, we've, people from our department have kind of emailed us different ideas. The slideshow that's going to be uploaded to the website will have many more websites. The websites where we have our puzzle of the day, the Tarsia websites, more information and a little bit more detail of how we use it, how it can be used, how you can extend it, how it can be used for peer assessment, and etc. I mean, there's about another sort of, well, I don't know, about another 24 to 30 slides on with a little bit more information. But obviously, we didn't have much time now. There's just a few things. I mean, hopefully, there's a couple of things that you might take away that would be useful. I think the Tarsia is definitely something that's been really good that we've enjoyed this year, and KenKen. But any questions on any of those things or any other things? Now, if you were interested, if you, we've obviously we printed out the KenKen, the Tarsia. If you're interested in sort of seeing how it works, having a go, you can kind of quickly see that it's good. It's good. It's kind of good fun for students working in teams to put it together. But I think we're finished. So, if there are no questions. Yeah, if you want to leave them, feel free to take the Tarsia with you. If you don't want them. Just leave them on the front at the end.
Oh, it's all on the What Works website.
If you log on to it, you require a password to get the solutions to this.
Yeah, the 2% answer is
This is WISH.
the solutions? I power I1 of
Okay.
5.
Yeah.
And second one is bigger. 5 power E.
Oh, okay. You'll find out. Have a look at the presentation. Or do you want to show the solution?
Yeah, I got the solution. Because